We are going to be working on triangle similarity, and we're going to show how to prove triangles are similar using the angle-angle similarity postulate. And the angle-angle similarity postulate is when two angles of one triangle are congruent to the two angles of another triangle, then we can say that they are similar. And we know similar triangles have three sets of corresponding congruent angles. We don't have to show the third because all angles add up to 180. And if two angles are congruent, then the third one has to be congruent as well. So it's kind of a shortcut. We only have to show two of the angles being congruent, and then we know all three are. So for our first problem, we've got lots of parts here. Explain why the triangles are similar. So that's part A. We are going to show they are similar by angle similarity. So I need to show that two sets of corresponding angles are congruent. Well, we do have two triangles here. And if it's hard to see it, if you want, what you can do is you can redraw those triangles and separate them. Because we have overlapping triangles, sometimes it can be a little bit more difficult to see which two that we're talking about. So when I look at my two triangles, now those are great triangles there. The top triangle, the smaller triangle, is WAN, and we know that WA is X, AN is 20. And we've got the big triangle, WRE. Now the length of WR here are X plus 4. I have to add those two numbers together. So this is X plus 4. And this base here is 36. So I've got my two triangles. We know that two angles are going to be congruent because angle W is a shared angle. It's the same angle W in both triangles. So the first angle we can say is angle W is congruent to angle W because it's a shared angle. So we still need two sets of congruent angles. We can prove all three congruent. We only have to do two. I can also say these two angles, angle WAN is congruent to angle WRE, or I could say that angle WNA is congruent to angle WER. Both of those have the same reason, and that's because they are corresponding angles of parallel lines are congruent. And if you had missed that on the diagram, you have these arrows right here telling me that those lines are parallel. Since the lines are parallel, I can use alternate interior angles if it applied, which doesn't apply here. I have corresponding angles, and so I can use my angle-angle similarity by proving or showing any two corresponding angles are congruent. I could show all three, but you only need to show two. All right, B, write a similarity statement. So how are they related to each other? In what order? So corresponding order, triangle WAN, top left right, is similar to WRE. Next one, solve for X. So I want to set up a proportion. So I want the ratio of corresponding sides. WA corresponds to WR. So X over X plus 4. The sides that correspond to each other get written as a fraction, as a ratio. AN corresponds to RE, so it's 20 over 36. What's the most important part when you're writing a ratio is to make sure that you are consistent. So since I went from the top triangle to the big triangle, on the first fraction I have to go from the top triangle to the big triangle. Whichever triangle you start with, that's the triangle you have to start with every time. Then we cross multiply, so that gives us 36 is equal to 20 times X plus 4. Distribute, 36X is equal to 20X plus 80. We move our 20X over. 16X equals 80. We divide 80 by 16, and we find that x is going to be equal to 5. All right, part D. Part D says to indicate the scale factor. So what did we multiply by? Since we wrote our similarity statement from WAN to WRE, I find the corresponding section. I'm going to use the number that I'm given. Because what if I made a mistake in my calculations? So I'm not going to use x or x plus 4. I'm going to pick the two numbers that I was given that I for sure know are right. So what do I multiply by 20? That's the scale factor to get 36. So we divide by 20. 36 over 20 is going to give us a scale factor of 9/5. That is going to be an enlargement because I'm getting larger. I'm going from 20 to 36. And then our last part here, part E, what is the similarity ratio? Well, if the scale factor is 9/5, the ratio is 5 to 9. Those are always going to be reciprocals of each other. All right, so next one. Write a similarity statement and tell how you knew they were similar. So I've got two triangles here, and if I want to prove that two triangles are similar, I'm going to use angle-angle similarity, which means I need to prove two of my three angles are congruent. When I look at the diagram, hopefully there's one jumping out at you right away. We have vertical angles. Those two angles are congruent. The other one you might be stuck on. When I'm looking at my diagram, I see these arrows. Those arrows mean I have parallel lines. So we can use parallel lines. This is my transversal. If this is my transversal, then alternate interior angles are congruent. Or I could have used OE as my transversal, which would have given me those two angles are congruent. So once again, you could show all three congruent angles if you wanted to, but you will only have to show two. So let's write our similarity statement, KOB. I gave you the first one, which means there's only one correct corresponding second answer. If I go from K to O to B, I want to follow those angles in the same order over here, so it's going to be REB. Again, we said by angle-angle similarity. So now it says explain or show mathematically. This is kind of a tricky question because when you look at it, I gave you information on this, on the side lengths. But we didn't prove that it was going to be similar based on corresponding sides because I don't know all the sides. If I knew the lengths of all the sides, then I could go ahead and find the ratios like we did in yesterday's video. But I have x's. X's could be anything. So I don't know that my sides are corresponding. So that's why we're using the angle-angle similarity. And basically we just have to talk about what we did. So 1, we have angle OBK is congruent to angle EBR because of vertical angles. Then for your second angle, because it's angle-angle similarity, you have to show two congruent angles. You could either tell me angle KOB is congruent to REB, or you could tell me the other corresponding or alternate interior angles. OKB is congruent to ERB, and that's because these are alternate interior angles of parallel lines are congruent. Both of those angles have the exact same reason. All right, let's get to our last question for this video. Are the following triangles similar? Explain why or why not in complete sentences. So this time we only have angles provided to us. So if they are similar, then the corresponding angles must be congruent. And looks good. We have 29 and 29. 51 and 100, those aren't congruent, therefore they're not similar. Nope, it's not that easy. So when we look at this, we have to check all corresponding angles. How do I know 51 and 100 are corresponding? We have 3 angles in a triangle, so we have to find those third angles. So 180 minus 51 minus 29 is going to give us 100. Oh, that might be looking familiar. Over here, 180 minus 100 minus 29 is going to give us 51. So this question can be a little deceiving. In this particular case, we are going to say yes, the triangles are similar because all 3 corresponding angles are congruent. And we only had to show 2 of them, so they would be congruent by angle-angle similarity. We have 29 and 29. We have 51 and 51. And then we have 100 and 100. So make sure that you have all of the information, that you're looking at all 3 angles before you make your decision. And that finishes up today's video.